Hello everyone. So today we would gonna talk about mathematical expectation in statistics. Um, so if suppose suppose we have single random variable. Let's say this is random variable is x, and this is random variable can take either. So it's either discrete random variable or it's continuous random variable. Now we will explain both cases here. So if it's discrete, if x is discrete, and we wish to find the expectation of this random variable x, so we have e of x, which is equal summation of x p of x, where p of x is probability mass function, and for the limit for the summation it will be x belong to the sample space. So this is the definition of the expectation of random variable x. Now in the discrete case, now in general we can say, so in general, if we have function called edge of x, so the expectation of this function edge of x will be summation edge of x p of x, where x belong to the sample space. Now this case is for discrete. Now if we take the other one, which is x is continuous, now x is continuous, so expectation of x will be the integral, in this case, x f of x dx, and let's say it's minus infinity to infinity. And also, again, we can say if we have edge of x is a function of x, any function of x, then we can say expectation of this function edge of x is the integral minus infinity to infinity edge of x f of x dx. Now we'll take two examples. The first example is discrete, and the second example is continuous. So let's take the first example. Suppose that x has the following probability mass function. So we have x values here, and we have the probability mass function corresponding to each value in here, the x. Now we want to find e of x squared, and the expectation of e to the power x. Now, as we know, the expectation of x is sum x p of x, and x belong to the sample space. So in this case, we have here discrete random variable x, so we will substitute x, so it's minus 2 times 0.1 plus 0 times 0.3 plus 1 times 0.4 plus 3 times 0.2. So minus 2 times 0.1 is minus 0.2, 0 times 0.3 is 0, 1 times 0.4 is 0.4, and then 3 times 0.2 is 0.6, so the answer will be 0.8, 1 minus 0.2 or 0.8. So this is first one. Now let us take the second expectation, e of x squared here. So that will be sum of x squared, p of x, the definition of expectation. So we have minus 2 squared times 0.1 plus 0 squared times 0.3 plus 1 squared times 0.4 plus 3 squared times 0.2. So 4 times 0.1 is 0.4, 0, 1 times 0.4 is 0.4, and 9 times 0.2 is 1.8. So the answer will be 2.6. Now we have the third one, the last one, is the expectation of e to the power x. So we have summation of e to the power x, p of x, where x belongs to the sample space here, and we'll take e to the minus 2 because x is minus 2, first one, and then times 0.1 plus e to 0 times 0.3 plus e to 1 times 0.4 plus e to 3 times 0.2. Now the first one is 0.0135 plus 0.3 plus 0.08. So it's 1.0873, and the last one is 4.0171. So the answer will be 5.4179. Now we'll move to the second example here. So in this example we have like continuous random variable x, follow exponential with the parameter theta. So the probability density function theta e to minus theta x, where x is greater than 0, and we're aiming to find the expectation of minus x. Now from the definition, let's write that. Let's write it down. The expectation of minus x, e to minus x, is the integral minus infinity. Sorry, it's 0 because the range is from 0 to infinity. So it's 0 to infinity e to minus x, and then f of x dx. So, and that equal 0 to infinity e to minus x, and then theta e to minus theta x dx. Now we'll take theta out of the integral, so 0 to infinity e to minus x, and then will be 1 plus theta dx. Now because we want the integral of e to minus x 1 plus theta, and then if we integral that, we need the definition of the we need the differentiation of the e to minus x 1 plus theta with respect to x. So what we need in here, we need theta, and then we need minus 1 plus theta, and then we need to, again in the numerator, we need minus 1 plus theta e to minus x 1 plus theta dx. Now as the differentiation of this function with respect to x will be minus 1 plus theta, then this all goes with the integral. Then we've got theta minus 1 plus theta, and in here we've got e to minus x 1 plus theta, and that would be infinity 0 here. Now minus theta 1 plus theta, so we've got here e to minus infinity, first this one, and then minus e to the power 0. And as we, because 0 times anything will be 0, so as we know, e to minus infinity equal 0, and we know also, and e to 0 equal 1. So minus theta 1 plus theta equal, then brackets, open brackets, will be 0 minus 1, and that equal theta 1 plus theta, and that will be the expectation of e to minus x if x is exponential with the parameter theta, x is continuous random variable. I hope you enjoy the video. Thanks for watching.